too.
Okay.
I feel like this is my audition tape. So, welcome to our presentation. We called it Understanding the Crisis. So let's go. Let's just. Okay. So we're going to talk a little bit about resources. So as humans, we live off of Earth's resources. We get our food, water, shelter, clothing, electronics, and much more. So everything we own actually comes from our planet. I don't think that's a surprise to anyone. So Earth has to have all the resources it needs to sustain itself. The only resource that Earth can import is energy from the sun. So everything that we use comes from the Earth, and the Earth can't be like, oh, I want to get something from Mercury or Mars or Venus. Like, they can't do that. So if the Earth runs out of resources, it can't import them from somewhere else.
Okay.
So we have limited resources. Because the Earth has to sustain itself, the resources available are limited. The Earth has something called biocapacity, which is kind of divided into two different things. So there is the regenerative capacity, so those are sources. So the natural or managed capacity to replenish the biological matter that people take from it, or waste absorption capacity, which is the capacity to reabsorb and neutralize the waste generated by human consumption based on current land management and resource extraction technologies, so like the carbon cycle and decomposition of organic waste. So something a little bit more about biocapacity. So per person shares the biocapacity that is calculated by dividing the total available global hectares by the world's population. So these are like some statistics here. But on average, one person consumes 2.6 global hectares. And obviously that's a problem because that's more than we can sustain. As human demand expands, there is less biocapacity available to support other species, so we're taking their food and their habitat.
So overshoot. We are now living in overshoot. It's where the Earth takes over 1 year and 7 months to regenerate what we use in a year. In other words, humanity uses biocapacity equivalent of 1.6 planets to provide the resources we use and absorb the waste pollution we generate in a given year.
So this is just like a little graph that I found, and it shows like what each country's overshoot days, so like where they have used up all their resources. So like we have like Australia is in like March, if it was to be like 1 year, right? And where are we? We are...
Canada's at the 13th of March.
Yeah, we're the 13th of March, and the US at the 14th, and then we go on, and actually Honduras is the only country that can like go the full year and not go into overshoot.
So causes of overshoot, the higher standard of living in a country, the greater ecological footprint of the population.
So some of these causes are like, there's 4 main causes. One is high rates of conversion of natural landscape into built infrastructure. The second one is high levels of public service, so health, education, using those. 3 is high levels of energy use, and the 4th is high level of personal consumption of food, goods, services, air travel, etc. So like luxury items. So some systems. So environmental problems need to be understood in the concept of Earth as a single organism, like a body, whose function is shaped by several interrelated and interdependent systems. So everything is connected, both in ways that you expect and you don't expect. So we have like planetary boundaries. So there's 9 human-induced alterations to Earth's subsystems that have the potential to shift the Earth into a totally different state. So we have a little graph here of the 9 boundaries. So red equals the high risk, so it's beyond the zone of certainty, and 2 are in this, which are the biochemical flows and the biosphere integrity. Yellow is increasing risk, so they're like, oh, I don't know really what's going to happen there. So that's like the land change, and again the other two, as well as climate change. And green is like a safe zone, so you're underneath the planetary boundary, and white, which these two are not yet really like confirmed.
So some drivers are economic growth, population growth, and energy use through growth and transformation.
So there's some ways like how to respond to these. So there's a risk management approach, which is humans solve problems as they arise. So solving problems is the source of like human progress, is like how people would like look at that. And then there's a precautionary approach, which is in cases of uncertainty and where there's a potential for harm, we should act to prevent the harm before the risk is already present. So I guess the main question is like, how close to the tipping point do we go in that? So then we have systems of thinking. So there's our level 1 is kind of like a reaction. So like we see the events that have already happened and we're like, oh no, China's flooded, we have to do something. Whereas the second one is, oh no, like the water levels are rising, China might flood, like we should do something about it there. The third one is like underlying systematic structure, so understanding, why China is going to flood and how that happened. And the fourth one is a transformative mental mode, so like, why is this happening, how can we prevent it, and it's just kind of like a combination of the three prior and a deeper understanding. Yes.
So level 1 thinking, so reacting to observable events or problems, linear thinking, seeing the world as a series of unconnected events. Level 2 ways of thinking, as just went over, you see connections between multiple problems or repeated events, recognizing patterns of events, behaviors, decisions. Level 3 thinking, structure, the social systems that support or promote the trends, so political, economic, and cultural.
And level 4 thinking, so system structures are shaped by dominant values, ideas, beliefs, and perceptions about how the world works. Mental modes, mind maps, worldviews are like undiscussable assumptions, so taken for granted, unexamined, and mostly subconscious. And they act as societal goals of a system, and thus the behavior and decision-making of organizations, governments, business, and individuals is shaped off them.
So, summary of the levels of thinking. So level 1 is identifying key problems, so what happened or what's happening. Level 2 is uncovering patterns or trends, so questions you would be asking is, has this happened before? Is it similar to other problems? And is it happening elsewhere? Level 3 is like a hypothesis, so what forces or structures are driving this trend? Why do you think that, and what evidence is for this? What theories support this? And level 4, uncovering beliefs or assumptions. So what is the goal of this system? Why are systems organized the way that they are? What assumptions or beliefs about the world are the structures based on?
So a little bit more about our planetary boundaries. So we're losing planetary boundaries. So even if we lose one planetary boundary, people are like, oh, so what if we go into like overshoot and global warming is in red, like, so what does that mean? So like we said before, like the earth is like, we need to think about it as one interconnected organism, so everything is connected, so it would be extremely difficult not to feel the effects of one in areas of the others. So if we lose one, we lose others in the process.
So what are the planetary boundaries? So these boundaries are biospheric integrity, climate change, land system change, freshwater use, biogeochemical flows, ocean acidification, atmospheric aerosol loading, ozone depletion, and novel entities. So what is biospheric integrity? There are two components to that, and one is genetic diversity, so the variety of species within an ecosystem or biome, And there's functional diversity, which is the range of things that organisms do and how they interact with the ecosystems.
And we're going to talk a little bit about climate change, because that's pretty much the most prevalent, what people know about the most. Like, that's like the big planetary boundary that's kind of like caught the attention worldwide right now. So what actually is climate change? So climate is different than weather. So when people go outside and they're like, oh, it's snowing today, there's no such thing as climate change. Like, that's not an accurate thing. Climate is the long-term weather patterns that can be expected in an area, whereas weather is the temperature outside on the day-to-day basis. And when someone says that we're experiencing climate change, it means that we're experiencing weather patterns outside normal ones for a prolonged period of time.
So what are the causes of climate change? So just to name a few, global warming is by a greenhouse effect causes climate change. The greenhouse effect is where more gases get caught in the atmosphere than necessary to keep the Earth at a steady temperature. And lastly, the greenhouse effect is caused by the actions of humans. So, you know, what kind of things that we're
Putting into the
putting
atmosphere.
into the atmosphere.
So ozone depletion, this is something that we hear a lot of, that climate change is causing ozone depletion, and that's actually not true. A lot of people think that, yeah, ozone depletion is causing global warming, however that's not true, but global warming is said to actually be causing ozone depletion, so it's the other way around.
So 2016 showed on this very lovely graph that it was the hottest year on record.
Just like you, honest thing on record.
Anyways. So, one of the effects of climate change as well is ice loss. So sea levels rise. So when ice melts, so like when sea ice melts, it doesn't cause any changes to sea levels, because the mass is already taken into an account. So whether it's an ice or it's like water, like it takes up the same space. What the concern is and what contributes to sea levels rising is when ice melts on land. And as you can see, it's gone up quite dramatically. So some of the effects of climate change would be altered precipitation patterns, biodiversity effects, changes in crop yields, human health impacts, extreme weather damages, so floods, tornadoes, hurricanes, typhoons, forest pest outbreaks, and sea levels rising. So Canada and climate change effects. So these are some of the effects that we can see here in Canada. So up north, there's been loss of permafrost, there's been like wildland fires, there's been droughts, heat waves, infrastructure failures, and storm surges. Like, I know that here on the East Coast, we've been especially affected by like abnormal amounts of precipitation or snow.
Yeah.
And here's some more.
Some more places. So on the west coast, we've got issues with forest depletion, agriculture, ecosystem depletion, bad water quality. Up in central Canada, we have issues of water availability, and here on the east coast, we have issues with aquatic resources, their depletion.
So what to expect with climate change? So freshwater resources, they're going to have some degradation and depletion. There's going to be species extinctions, ecosystem stress, flooding of coastal and low-lying regions, marine species will be threatened, there'll be ocean acidifications, food production decline and food insecurity, urban impacts and rural impacts, so it's not just going to affect like one group over the other. There's going to be human health risks and social unrest because of all these things. So it's going to impact how many refugees there are, what there is going to be in terms of military conflict, economics, instability, and political instability as well.
So climate change as being political, so United Nations Framework Convention on Climate Change started in 1992. The goal that they put out was to reduce greenhouse gas emissions enough to avoid dangerous levels of warming. Signatories are called parties to the convention, and this is implemented through specific agreements and protocols. Continuous negotiations are in the making. Annual conferences of these parties happen every year.
So then the Paris Agreement came into effect. And so what their goal was to hit peak emissions as soon as possible and then start reducing. And their plan was to submit plans every 5 years for how to ratchet emissions downwards and move towards low carbon and a resilient future. So the Paris Agreement came into effect November 4th, 2016, and it was ratified by 55 countries representing 55% of the global emissions. So we just want to leave you guys with this question of what you can do to help climate change. With this lovely little drawing that says "The world is in your hands."
It's quite cute.
Yep. And that's our presentation. Thanks, guys.